One of the properties of water is cohesion and adhesion. Since water is a polar molecule, H2O molecules form hydrogen bonds with each other as the positive hydrogen in one molecule gravitates towards the negative oxygen in another. This creates a sticky molecule, much like how these pups want to stick together. Okay. Okay, ready? Yep. Water is also very adhesive to other substances. In a plant, water enters in the roots and climbs up the walls of the xylem through this property. Water molecules are attracted to both themselves and other molecules, and this water molecule loves the grass.
As we know, most substances are dense when they are in solid form. One of the most important properties of water is that ice does not follow this trend. Solid ice is actually less dense than liquid water. This is because the hydrogen bonds between water molecules form a stable, spread out crystalline structure when frozen, as opposed to the unstructured hydrogen bonds that rapidly break and reform in liquid form. This is why Apollo, our ice, can float in this flow of water. Okay, yeah,
Full of water.
I want to say tree.
Water is extremely resistant to changes in temperature. In fact, water has the highest specific heat capacity of any liquid. Specific heat is essentially the amount of heat that 1 gram of a substance has to absorb or lose in order for it to change its temperature by 1 degree Celsius. Since water has a high specific heat, it requires a lot of energy to significantly heat it up or cool it down. Our water molecules can run for a very long time because it takes a significant amount of energy to be exerted in order for them to get tired out or change temperature. This property is vital to life as water serves as the temperature moderator of the Earth.
Water is able to moderate its temperature due to its high heat of vaporization. The heat of vaporization is the amount of energy required to vaporize 1 gram of a liquid into a gas. Water, due to how it often makes hydrogen bonds, requires a lot of energy to vaporize. The more hydrogen bonds a substance makes, the more energy needed to break those bonds. To put it simply, it takes a lot of energy to change water's state of matter. As we know, water requires a lot of energy to significantly change its temperature, so the amount of energy required to change its state is massive. Just like how these good doggos require a ton of energy to change from speedy boys into sleepy boys.
Breathy boys.
Breathy boys.
Get it. Good boy.
Ashton, do you want to read the sprinting one?
That was really fun.
Do you want to read the one with your side?
I mean, sure. Yeah, sure. I'll do that.
Oh, wait. Now you listen.
Here he comes. Hey. Good boy. Come on, Em. Come on, Em. There I go.